Hi, it's Trisha Lee again. So I'm here outside my dad's shop, and even when I was working here, I knew that I didn't want to do this for the rest of my life, and also I knew that I was going to be involved in bigger things. So anyway, my dad's been nice enough to let us use some space out behind his shop here for our solar power company, King Sunshine Solar Systems. So right now we're going to talk to the inventor of this free energy device that we're trying to build. He doesn't like me to call it that. It's a solar power device that we've been working on for 6 years now. So this is where we're at with it. And there's the video that's always at the top of this blog category that shows you some basics, and we're going to get a little bit more in-depth information from our inventor here. So can you introduce yourself and then tell us a little bit more about this device that we've created?
My name's Laurier Lievre, and I'm the inventor of the solar heat collector. And it's a new type of device for making electricity. We started with a concept where we wanted to create heat and be able to produce, basically create heat for heating homes. And
Oh, we just got interrupted here. There's a truck going into the slave cave. Box liner going to be prepared. That's what I used to have to do. We'll just wait till they get the truck pulled in there and the noise goes down, and we'll continue.
all right, so this is what we call the housing for the lens. And what the lens is a Fresnel lens, and it works like a giant magnifying glass. So essentially the sun hits the lens and it focuses down onto a spot on the inside here we call a receiver or a target. And in this target we pump through a heat transfer fluid which heats up to 200 Celsius, and from the receiver on the inside it gets pumped through this line and it goes into this invention which is called a electro crown. And what the electro crown does is it takes the heat from the heat transfer fluid and uses it in a thermoelectric effect to create electricity, and essentially that's how it works.
Okay, so the video that's also up there showing this device was made back in April, and it showed it generating a small amount of power. What has been the obstacle that has kept us from demonstrating this device powering like an appliance?
Basically, the problem we discovered on Earth Day, ironically, was that we were losing too much heat through this length of tubing. So what this tubing is an insulated silicon tube, which is about a 1/4 inch in diameter, and all this material around it is insulation. And so what we're in the process of doing is using something called a jacketed tubing. Excuse me, it works essentially like a thermos, and we've been losing approximately 150 Celsius going from here to here, which results in a low amount of electricity generated. When we switch this tubing with a vacuum jacketed tubing, we're only going to lose maybe 20 degrees Celsius, but we are tweaking this tubing so that it might perform even better than that. And the difference is that there's basically only fiberglass insulation. It's the same insulation you have in the walls of your house or your building. Vacuum jacketed tubing is a tubing that has no air around it, so it's similar to a thermos. How they have the walls in between the outer jacket and the inner jacket have no air in it. The air has been evacuated, creating a vacuum, just like in outer space, and heat cannot transfer through that vacuum.
So how much longer do you think it will be before we can do another demonstration showing this making more electricity more efficiently?
I would say we are waiting for some stuff that's coming from Europe right now, some parts, and that's going to take about it's about a 30-day trip to get it from Europe to Canada. So, and it just got ordered. So I would say probably 45 days we should be up and running and making electricity.
All right. Well, we're looking forward to seeing a future more illustrative demonstration of this, and we will keep you updated. So keep checking out this blog and see how this progresses. And one more thing, Larry, what do you think that this device will be able to do for people out there watching?
They'll be able to provide direct current electricity to run their homes with using far less space than an array of solar panels, and it'll also create heat for heating homes.
Great. And so what was the cost of something like this going to be?
Uh, R&D costs or manufacturing costs?
Well, for the people watching that say, hey, that's cool, I want to get one.
I think we're going to be selling them for $3,000 Canadian dollars.
Cool. So, just to share it with you,